I think the question 3 on the homework, I don't think you got it right, but there's a lot of people that had trouble with this. Now, I'll walk you through, or what I could do is, you see those elements on the top of the screen, Diana?
Yes, I do.
Can you sort them from the smallest to the largest in size? So the question here is, sort the elements from the smallest to the largest in size.
Okay.
Because I think since you got it right, I don't want to teach it and have you come up with it. And then based on that, I will explain how to do if you encounter this problem on a test. We're going to do different kinds of the same thing, but we're going to start with this. I think everybody that even is planning on doing a redo seem to have got this one wrong. So write down all the elements. That's why I have the periodic table handy for you.
Okay.
Start them from the smallest to the largest. Now, when I mean smallest is, you go like this. Whatever is here is the largest, and whatever at this end would be the smallest.
Smallest, okay.
Because I think a couple of people may have got the sequence right, but they had it flipped. So definitely question 3 on homework has been question 3, 4, and 5. They're probably the ones missed by most people.
Okay.
So I'll give you like a 5-minute or less than that. I mean, it shouldn't take you that long.
Okay.
But when you have it, you can let me know. Or when you finish it, let me know. I don't have to have your sequence, but I can explain it and see if you got that right. Okay?
Okay. Okay.
But I want you to have your time to first complete it.
Okay. Less than a yes. Less than SE. Less than G. Less than S.
You have it?
I think so.
All right. Now, I'm just going to, since you're the only person, I'm going to speak for the rest of them.
Okay.
You. So when I teach this concept in my in-seat class too, okay?
Okay.
The common problems that I noticed there's a few of them. First is they don't read what the question is asking. Okay, that's the first problem I have seen with about my 25 in-seat students and 28 out of you, about 50 people. I think only 2 people really get this whole thing right. Everybody else makes some kind of mistake.
Mm-hmm.
And the first problem is they don't read what the question is asking. This question is asking about size.
Size
is also atomic radius,
Use.
or size. They're the same. Let me go back. Atomic radius or size is the same thing. I'm going to try to do it all in this screen.
Okay.
That's so this is all the same. And then smallest to largest means you're going like this. Okay?
Okay.
That's the first thing that people seem to be missing. And the second thing they seem to be missing out is, let me get a different color, is they're they're doing all the elements at the same time. They're looking at it holistically, and that's a problem.
Mm-hmm.
And if you run into the same problem, then I suggest you also do the same. Don't look at all the elements. And the way I figured out that people are doing that mistake is I sat with each and every one person in my in-seat class and have them explain how they are doing it. So which means I dedicated a whole class just for that. I sat with each every person, all 25 of them, and explained how they tackled the problem. Of course, there were different views, but the common problem was they were looking at all elements in one go, and that's a you will run into a problem. The way I see it is pick one element, okay, pick one element, and then do like a spiral around it, okay?
Okay.
Fix one element in your mind and then work around that one element. You got one more, one more, one more, and then you will be done with the whole list. Some people, another problem, some people, that's one thing is they're looking at everything at the same time, and what happens is by the time they're missing out elements. That's a problem. So if there's say 10 here, when they finish, they have 11 or 12. They have more, or sometimes they have 7.
Yes. Mm-hmm.
So you can only work with elements given on the list, right?
Right.
So that's the first problem is they're not reading whether it's size, energy, or electronegativity. The second is they're looking at everything. And the way I have told them is some of them, my in-seat people, can bring color pencils to class. You guys don't have that problem since you're working from home. Is as you work each element, circle that element on the periodic table or strike or do something so you're not over repeating that element, or at least you know that out of 10 I've done down to 9, down to 8, down to 7, down to 6, down to 5, etc. So one approach that I have seen work is the bottoms up, which is again the rule. That's another thing. They are confusing the size with the ionization energy, okay? I'm going to write the rule one last time here because this is everything we do tonight is going to be opposite. Atomic size, generally it increases from top to bottom in the periodic table. Top to bottom in the periodic table. That is, you go down, and then it generally decreases as you go from left to right in the periodic. This is a general trend. I mean, of course, there are some exceptions which we did not go into. Okay, this is the general trend. And what I have seen works the best is from this list, okay, find one element that is on the furthest left, on furthest right on the periodic table, okay? Furthest right to the very rock bottom and work your way up. Remember I said you have to fix that one element and work around that element, everybody else? And what I mean here is you have these bunch of elements. Go find one element from this list that's at the very rock bottom. I will not test you more than the 6 rows. I will not test you this. It will be the 6 rows right here. Find one element that is not only at the bottom, but is more to the right. Okay? That is going to be the biggest. Okay? Now, all these are elements. None of them are ions. We're going to look at a couple of examples that is also something that have troubled people. So let me go get my black color. Now, as I said, find one element. Let me write it down. Find one element that is at the bottom, that is at the rock bottom. And furthest to the right. The reason I say this is something I came out after talking to all 25 people, how they are thinking. So that takes time. So I
Mm-hmm.
dedicated one class just to do this. I sat with every one of them,
Okay.
asked how they solve it. Literally, I did it for all 25 people individually. And what works, my in-seat people have got over that hurdle. All, I think 24 out of 25 people can do this now with no problems. So, and the only way I was able to figure out is find one element that is at the rock bottom and furthest to the right. Which element do you think? Because the reason I say that is somehow the brain, at least for this case, seem to work better when you're doing a bottoms up approach, like bottom to top. No one seems to be troubled. It's only when they're troubled when it's left to right.
Mm-hmm.
Okay? Find one element on this list that's at the rock bottom, but is also more to the right.
Be the BI.
That is
Bismuth.
correct. So that means that is not necessarily the biggest, but we're going to work our way up around that bismuth as our pillar. Okay?
Okay.
The bismuth is the focal point. That's what I meant to say. I think I said the biggest. That's not what I meant. What I meant is this is our focal point. Okay?
Okay.
All right. Now, this is what I meant is strike out bismuth and circle bismuth. If you do it if you do it like I would, I'm not saying you are, but I'm saying you as in all of you. If
Mm-hmm.
you if you're doing it just in your mind, it's not something I highly recommend. It is something you got to work it out. You got 2 hours for a test, which is shouldn't take you more than 40 minutes. So you have an extra an hour and 20 minutes floating around. So there is no reason to rush into any of the questions. There's a
Okay.
4 or 5 questions on the test where you have to spend more time. The rest you don't need to. Okay. All right, we got bismuth down. You see how I'm going systematically? I'm circling that element and I strike it out. All right, is there any element in the same row as bismuth? Is there any element that is in the same row as bismuth?
Uh, yes. No.
See, that is exactly the problem, Diana. This is what I found
Oh,
out.
so I should have went to the left.
Yeah, there's
That's going
still
up.
tungsten and osmium.
Okay. I went up to the top.
See, one student had that same problem that you had. They cannot visually match the elements in the list to the elements in the periodic table.
Okay.
And that's a problem. This is why they can do it is because they're looking at it as a cluster. They're not looking
Yep.
at it one thing at a time. Okay?
Right.
Okay, let me close this notification. Now you see, I did notice right away, I have 2 more elements that are in the same row as
Mhm.
my, so I'm going to go strike those out, okay?
Okay.
Now 3 out of whatever many is down. Now, where do you think W and OS are with respect to bismuth? You got to go to the rule. Osmium is to the left of
Yep.
bismuth, right? And
Mm-hmm.
tungsten is further left of bismuth, right?
Mm-hmm.
So which one of these two do you think is bigger? W or OS?
It's going to be the W.
Yes, so W is here, right?
Mm-hmm.
And then OS is in between the two. You see, 3 down. All right, let's get a different color for the second row. Now you work that's it. We now know we finished the 6th row, right?
Mm-hmm.
We know for sure we don't have any more else in the 6th row, right?
Right.
All right, let's go to 5th, top 1 row up. Is there any element on this row is in the list of elements I've given you?
SN.
Okay, circle that. Okay, let's strike out SN. Okay, is there anything else? Take your time because this question, the more you rush, the more you're going to get it wrong. I don't think there is.
That's it.
That's it, right?
Mm-hmm.
Now, where do you think tin is with respect to all three elements on the bottom? Is it above or below?
It's above.
So do you think that's bigger than these three or it's smaller than these three?
It's going to be smaller.
Very good. How difficult was that? Let's strike out 4 done. You see, I'm not putting it in the sequence, right?
Mm-hmm.
All right, now let's go. You can check it. 1, 2, done. 1 row up. Okay, are there elements in this row that's on the list? Sure, there is quite a few.
Yes. There's
Just go and find elements in the list and tell me one at a time. Again,
okay.
the reason people can't do this is they're looking at it as a cluster.
Mm-hmm.
The more you look at it as a cluster, the less you're going to ever understand it. Even if you know the rule, it's going to be difficult. Let's go to 4th row. Find one element. All right, I see CO, right?
Mm-hmm.
Okay, strike out that immediately. Don't wait, okay?
Okay.
Strike out immediately. It's done. You've taken care of it. All right,
Okay.
let's, there's chromium. I see it. It's in the list. Pick whatever you see and start erasing it. I see GA. Start striking it. Circle it, right?
Mm-hmm.
You can use different colors if you want.
Okay.
And then there is manganese, which is also,
Yeah, man. Mm-hmm.
and then there is, and then what else is there?
Yeah,
I think that's it. The rest is all 1 row above.
Mm-hmm.
All right. Now, are any of this going to be bigger than the 4 below? Tin, W, OS, and bismuth?
No.
Okay, so they're all going to be small.
Mm-hmm.
Right?
Mm-hmm.
Which one is furthest to the right? GA, right?
GA.
So that's going to be the smallest, right?
Mm-hmm.
And then it's CO, right?
Mm-hmm.
And then it's MN, and then CR.
CR. Mm-hmm.
Okay, now you see we are done with 8 elements in the list. The reason I'm working with you, it's going to take time, but normally if you do this approach, you should be able to not only finish fast, but get it right. All right, we're done with 4th row. Are there any elements in the 3rd row is on the list?
Yes.
There's quite a few.
Uh-huh.
Sodium and magnesium. Go and strike it out. And then we also have sulfur, phosphorus, and chlorine, right? Silicon. There's quite a few. Let's strike out all those. Right?
Right.
Now, do you think any of this 5 is going to be bigger than anybody else below?
No.
No. So
Right
they're
down
going to
below.
be small. And which one will be the smallest of the 5?
Chlorine.
Very good. So I'm going to say chlorine's going to, well, chlorine's going to be further, and then sulfur, phosphorus, silicon, magnesium, and sodium, right?
Mm-hmm.
Sodium's going to go right here in front of the GA, right?
Right.
All right. So this is the smallest so far, which means we're left with only 1, right?
Mm-hmm.
Which is this.
Lithium.
So that should go somewhere here, right?
Mm-hmm.
So what have we done is we've written the arrow like this. So if you go back, let me get my eraser. I'm going to erase the rules because we don't need those now. I need the space to fill it in. Now the key here is, like I said, pick one element for all of them, except I think ionization energy and electronegativity are a little tricky. But if it is just the size, again, we're not dealing with ions, okay? The whole perspective changes when it's ions.
Okay.
All right, so let's go and get our pen. Now we're going to start from the smallest to the largest, right?
Right.
So this is our smallest, right? This is our largest.
Mm-hmm.
We worked our way back because when you do the bottoms up approach, I would say 20 out of my 25 students are thinking like that. They're never thinking as left to right away. They're thinking as bottoms up, work their way up 1 row at a time. Mm-hmm. They were still making mistakes, but what I'm saying here is that is how their mind is thinking. I think a lot of you would find that because students think alike. most of them do.
Mm-hmm.
So we're going to start filling it back. Lithium, chlorine, sulfur. Use the same. Obviously, this is not the exact homework problem. Okay, then I beat the purpose because I'm literally giving you all the key. That's not what I want to do. I want you to understand it. So basically, I'm just working my way back. Now, when we go to the next set where I'm going to give you ions for the size,
Mm-hmm.
I'm going to give you time to work it out. Since you're really the only participant at this moment, you're helping everybody else with you. So now that's your smallest,
To largest.
largest. This is how the brain thinks. Most of the students are not thinking from top to bottom. There is a few that can do top to bottom. There's a few that can only start from the leftmost. There's a few that can only start, but 90% of my in-seat students somehow go pick the element. When I told them pick one element and work around it, they all seem to pick that element furthest to the right on the rock bottom.
Mm-hmm.
Then we talked about it. Why did you all go with that one option? They think that, oh, it's bottoms up seem to be easy for us. I told them whatever approach works for them, works for them. But this is recorded, so you don't need to write it down if you don't want to. It's all recorded. What I highly recommend is watch these videos because we're reviewing week 2 completely in here.
Okay.
Week 3. So I would recommend you watch these sessions thoroughly and practice any problems you already missed one more time on a section of paper before you take the test.
Okay.
The test, you get only one attempt. Even though you have 2 hours,
Okay.
you're still not panicking, but once you start, you've got to finish.
Right.
So I would make sure I would do this correctly and redo that same homework problem number 3 without any solution, and then match it to what you have. If you have the correct answer, that means you've got a good concrete understanding of the concept.
Okay.
Even if one element is wrong, that means you don't know. You got to go back and watch the video again and then go back. So you have till Sunday to take the test. So there's no rush to have it done. So let me get rid of this and okay. What I'm going to do now is bring this problem up. This is another one. We're going to work this problem in 2 ways. Let me get my phone. This is one that has plagued people like crazy. So let me get this also on screen. Since we don't really use the bottom portion of the periodic table, I'm only going to use just that. All right, so this is a problem that almost everybody got it wrong the first time they tried, okay? Now we're going to use the same ions for 2 different cases. The first thing I want you to do is sort them. This is the question. Sort the ions based on size. We're going to do this first because I think only 2 or 3 people really got this right. First, let's do it for the size, and then let's do it for ionization energy. And that way we cover a broad spectrum of example.
Okay.
All right, so I'll give you 5 minutes. See what you can come up with. I mean, there's 2 things you got to remember when you deal with ions. First thing is the balloon example I gave, okay, for positive ions. So if this is the balloon, this is +1. Balloon becomes smaller for +2 and +3. This is simple as I can tell you. This is +3.
Okay.
As the number of positive charge is like losing electrons. Positive charge is losing electrons. It's the same as losing air. So the more air you lose, the more electrons you lose, the smaller the ion. So this is the first thing. So the ones with the highest positive charge are going to be the smallest. But then between them, you have to apply the rule for
Okay.
size. Okay. First, you got to figure out which ones are plus ones, plus twos, and plus threes. And then you apply the rule. So let me write summary of it. Figure out, or actually best way would be to separate plus ones, plus twos, and plus threes. And then apply rule within, apply atomic size rule within each group, with each group containing. What I mean by group is, say you have plus ones, say you have a large number of plus ones. This is one group.
Mm-hmm.
This is the only way, again, this is all tips. This is the only way you're not going to make a lot of mistakes. So plus twos and plus threes. Group them first.
Okay.
And then apply the rule within each group and then write the sequence out. And one with the most positive charge is gonna be the smallest, but then I always purposefully give, in this case, I think, yeah, it is, there's only one with the
It's a
plus.
4 plus.
The rest, I made it more difficult in the plus 3 area. So there's always ups and downs to both examples, but in this case, no one seemed to have trouble with the plus 4s. It's the plus 3s and plus 2s.
Mm-hmm.
So all you got to do is, just like I did, draw a big oval and put all the plus ones in there. Put all the plus twos in there, threes in there, fours in there. What it does is it takes away the cluster. Again, people are looking at all this as a giant thing, and there's no way you get clarity out of it.
Mm-hmm.
So go ahead and take like 2 or 3 minutes, even if you don't have it correctly done. If you have it somewhat 90% done, then we can work it up.
AD.
All right, Diana, let's proceed.
Okay.
Now, if you see on the screen, I did not solve the problem, but instead I just put them all in like groups, okay?
Mm-hmm.
We know that the one with the +4 is going to be the smallest because going with the analogy of a balloon losing air is same as losing electrons.
Right.
I think something I have still not deviated from the concept map that I've told you all. Everything you learn, I'm tying back to everything you have learned or will learn. I will not just teach you a concept that's totally off topic, and that I don't think I've done that. 4 plus means it's losing electrons, right?
Mm-hmm.
So clearly that is the smallest.
Right.
No problem in this case. All right, so
Right.
done. Now, again, the reason why many people don't get it right is because sometimes they're seeing calcium 2 plus as 3 plus because they're looking at it as a giant cluster.
Mm-hmm.
You look at that list on the top from here, if you look at it all in one go, unless you're extremely proficient to read that kind of cluster effectively, you're going to get it wrong.
Right.
All right, I'm done with one. I'm going to go back and strike out that. Let's come back again to this list here. We got aluminum, gallium, chromium, cobalt, and bismuth, right? They're all +3s, right?
Mm-hmm.
Out of this 4, which one is at the rock bottom or furthest to the right?
Furthest to the right.
Furthest to the right and the rock bottom. For that list, which one is at the bottom? Rock.
Oh, bismuth.
Bismuth, right?
Mm-hmm.
So you think, I mean, you just told me that among those 5 things in the +3 group, bismuth is at the rock bottom, right?
Mm-hmm.
Is there anything else on the same row as bismuth within that +3? I don't think so.
No.
Is there, so that means bismuth is the biggest on that list, right?
Right.
Okay, that means bismuth done, bismuth done. Now, all right, we're done with row 5 or row 6 for +3s, right?
Mm-hmm.
Moving on to row 5. Is there anything else in row 5 that's in that +3 list? I don't think so.
No. Mm-mm.
Okay, so put a cross mark, means we don't have anything in it. Moving on to row 4. Are there any elements in this +3 pile is in this row? Yes, there is, right? There's gallium, there's chromium, and there's cobalt, right?
Right.
You see, that's why I'm using different colors. Now, same rule, apply the rule. Which one do you think is biggest of the 3 when it doesn't have a charge? Gallium, cobalt, or chromium? They all have +3s, but which one do you think is the biggest of the 3?
Chromium.
All right, very good. Chromium, 3 plus.
Mm-hmm.
And then cobalt, 3 plus. And then Ga, 3 plus. Right?
Right.
Within the +3, we got 4 done. Only one more to go. Where is aluminum with respect to everything else in that +3 pile? So
It's above.
right? So should it be the biggest or smallest?
It's going to be smaller.
Very good. So, all right. So we're done with the sequence. You see, if I get rid of this Mn4 plus from here and put it in front, I'm done with the smallest to the largest for the +4 and +3 groups, right?
Mm-hmm.
Now moving on to +2. which one of this bunch of elements in +2 is at the rock bottom and furthest to the right?
Furthest to the right. Copper.
No. PB. You see?
We got a P. Oh, I missed that one.
You see?
PB. Yep, I see
Now,
it.
this is the problem, is because if you do it directly off the list, again, I'm not saying it's impossible to do. Everybody can do these. None of this is very difficult, but it's the thinking part that suffers because they're looking at it all in one big picture. You're gonna get it wrong. See,
Right.
I separated them out. Now this is all I have to work with. When I finish with this, I'm finished with the problem.
Okay.
Okay, PB is at the very rock bottom, right? Is there anything else to the right or left of PB? Looks like PB is the dead end, right?
Right.
Okay. All right, there is nothing definitely to the right in that same row. You're focusing on the same row, okay? So PB2 plus is the biggest of the bunch, right?
Right.
All right. Is there any other element? Okay, we're done with PB now, right? Is there any other element in the same row as PB before you go to the 5th row? Is there any element? Yes, there is.
BA.
There is.
Barium.
Yeah. Is barium to the left or right of PB?
To the left.
So is it bigger or smaller?
It's bigger.
Very good. So BA2 plus goes here. Now strike out BA.
Okay.
There is nothing unsystematic about it. There is, I mean, you literally have to make some other mistake out of what you're doing to get this one wrong. Okay. Now, since you are working from home, you have the option of having this video up while you even take the test. You have that option. I don't think the people in. All right, we're done with 2, right? We did affirmatively say that there are nothing more than the barium and the lead in this row, right?
Right.
Right. Moving on to row 5. Are there any elements, any ions in this pile is in this row, row 5?
CD.
CD, where is cadmium? Right here. Very good. Right? So let's check that out. And I don't believe there is anything else. And is cadmium above the 2 that we already finished, right? So
Yes.
is it bigger or smaller?
It's smaller.
Very good. CD2 plus. Right?
Right.
All right. 3 done. 4 more to go. Sorry, 3 more to go. Moving on to row 4, right? Are there any elements here that are in row 4? You bet there is.
There's copper.
I think they're all in row 4.
Are they?
Yeah, calcium, copper, iron, manganese. They're all in row.
Manganese.
Calcium, again, copper, manganese, right? And iron. So they're all in the same row, right? Strike them out. Now, you may want to give a different color. So let me actually go back and give it different colors so that, I mean, people watching it later probably would lose track of it. So calcium, right?
Right.
Manganese, copper, and iron, right?
Right.
So I'm going to strike those out with the same color. All right. Now, are any of these elements going to be bigger than what we've already solved?
No.
Okay, so now which one is the biggest of the 4?
Calcium is the biggest.
Very good. So put it all the way at the very end of this +2 pile, right? Okay, now, oh, is it the biggest or smallest? Oh, biggest of the 4, right? So let me go back and write it on this side. So calcium is the biggest on this pile.
Right.
And who's next on the list?
Then there's
Manganese.
manganese.
Okay, and then keep working your way back. CO2 plus, sorry, iron, right?
Iron.
Iron 2 plus, and then finally Cu2.
Copper.
That's it. Now write them all as one giant sequence. So I'm gonna try my best to get rid of this right here and write it up there. Okay, so because I don't want to erase those files, because I think when people rewind it, they want to see that. So I'm gonna just go ahead and write them all here. So let me get my blue pen again. So this is the smallest, MN4 plus,
Mm-hmm.
AL3 plus. You don't want to do this directly. I mean, if you're me, yeah, I can do it. I can say that with confidence that I don't. I may make a typo mistake when I do it, but conceptually, I know the stuff. So I won't make a mistake. But because there's experience put in it, that's probably why. But I wouldn't directly start putting them. Even if the question is worded differently, you should still follow this format. So you're guaranteed. You don't want to lose points. That
No.
despite, I mean, we've done enough work on this. Typically, all this is shoved in maybe a half an hour lecture, but we spend a lot of time on these because if you don't understand it, there you go. It's going to be the smallest. That's going to be the largest. Does that make sense?
Yes, it does.
Now, I don't think many people got this right, so that's why we did this. Just the way there is a lot of systematicity in it. Okay, there is. I don't like any of my students to try to memorize any of this because practically it's not possible, and you're not going to get it right if you memorize.
Mm-hmm.
All right, moving on. What I'm going to do is it's recorded, so if you have not written, that's okay. I'm going to get this. And this is where I think 90% of the class would get it wrong. I think another thing is you got to go back and watch all videos more than once.
Right.
Some of them, yeah, you get it right away. I think we are at a point where things are going to get, I'm not purposefully making it hard, but chemistry is abstract. And at some point, there is going to be a concept that's going to be easy for you. It's going to be difficult for a person sitting next to you. And what is easy for that person would be so difficult for you. And that's why, watch the video. All right, here's the periodic table again. We got the same exact question, same exact set of ions, but this time I'm going to have you, this is question 3 for the day. Sort ions. We're going to do one more example that's going to be the difficult of all of them. Sort ions based on ionization energy. Now, I will never ask you ionization energy with a negative because it just doesn't make sense, okay? Usually positive ions is what's given for ionization energy. There are 2 basic rules, just like we did size. The second rule is actually the rule for ionization energy, which is ionization energy is increases left to right. I'm writing shorthand because I need all the space I can. Decreases top to bottom. This is the rule 1. There is another rule that I mentioned it in the video, and I think I mentioned it when we practiced it the previous time, is ions with more positive charge have higher ionization energy. I mentioned this. I think everybody forgot that. I think they only applied one of the rule. And then they combined the size and the ionization energy. That is a bad mix. These are the 2 rules that we have to apply. Now, rule 2 doesn't come in picture when it is just an element. Rule 2, let me put a star and write like they do it in a credit card. It's only applicable for ions. Rule 2 does not apply or even becomes an issue when it's elements. But when it is ions, you have to apply. Now, don't apply this rule for size, okay?
Okay.
You're going to get it completely wrong. This rule is only applied for ions when you're dealing with ionization energy. Don't apply this rule even if you're just dealing with elements for ionization energy. This is only needs to be applied when it's so. Go ahead and you have this precious information in front of you. Go ahead and give it a shot and sort them from smallest to largest. Get a different color. I'll give you 5 minutes because there's one more question I do want to get through.
So let's see. Let's see. Okay. Threes. She's left to right. Top to bottom. A. Increases top to bottom. Increases left to right. CR is less than GA. C. CO. CR increases left to right. G is bigger. C. R is C. Decreases top, so this is smaller. 3. You gotta be hot. These things. Please be hot. Decreases top. So be below.
Got it, Anna?
Not completely.
Okay, so you must have had, again, with chemistry, the problem is I don't think anyone does not know 100% of the material. They all know 80%, 70%. That's where and then they falter because of panicking. Okay, everyone in the class knows more than 70, 80% of all the questions. Right? So these are the two rules. Again, don't apply rule 2 if it's just an element. All right?
Okay.
So help me out here. All right. So is there an element that has the highest positive charge?
Yes, Mn.
Okay. So should it have the highest ionization energy or the lowest? What does rule 2 say? Ions with more positive charge have higher ionization.
Higher. So it would have higher.
Exactly. Since there's only one, we can move on to the remainder. Okay?
Okay.
Same deal like previous case. you want to pile them first in like charges, okay?
Mm-hmm.
So let's get the plus threes. What are the plus threes we have?
The Bi,
Okay,
Al,
okay,
Cr,
okay,
Co,
okay.
and Ga.
All right. Now we do know that they have the highest ionization energy compared to the plus twos, but it's going to be smaller than plus fours, right?
Right.
All right. So again, here you apply the rule. Okay, if you pick the one that's on the rock bottom, that's going to have the smallest ionization energy, right?
Right.
Because which one is the smallest on this list? It's bismuth.
Bi.
So Bi is going to have the smallest, right? So strike it out and go circle that. So it's done. All right. I don't know if there is anything else on the same row, right?
Right.
Okay, done with row 5. Is there any element or ions in row 5 that's in the pile plus 3? We're only focusing on the plus 3 pile, not even on.
No. Mm-mm.
All right, so nothing here. Our search came empty. So moving on to row 4. Are there any ions in here that you can match to the elements in the periodic table?
Yes.
Yes, there's quite a few, in fact.
There's Ga,
Okay,
Cr,
okay.
Co.
CO, yes.
Mm-hmm.
That's
And
it.
I think that's it.
Okay. Now, these 3 things are above bismuth, right?
Mm-hmm.
So do you think they have relatively higher ionization energy or lower?
Above. Decrease this top to bottom. They have lower.
No, they have higher, right? Chromium, cobalt, and gallium are above bismuth, right? So top to bottom, it decreases, right?
Oh, right.
Bismuth should have small, and the 3 should have higher, right?
Right. Mm-hmm.
They're in the same row. Now, if you notice, all my questions, there's a pattern, okay? If you understood that pattern, you're never going to get any chemistry question throughout the course wrong. I follow a pattern. Only very few students can see the pattern and spot it right away, okay? That's very, very few, okay? All these 3 are in the same row, right? If
Right.
you notice, we're on question 3, and every example we've done, I've always made sure there's a bunch in row 4. There's a bunch in row 4. The elements are kind of follow a pattern, right?
Okay.
Now, which one of these 3, we know that it's above bismuth, but which one of the 3 would have the highest ionization energy of the 3?
Increases left to right. Ga.
Very good. So Ga goes right here, right?
Mm-hmm.
And then comes cobalt, and then comes chromium.
Chromium. Mm-hmm.
All right, we're done with plus 4, and we still got one more. Aluminum is above all these folks, right?
Right.
So where would it be with respect to all the remaining 4 with the plus 3s? It would be
It'll
higher?
be in front of gallium.
No, it would be above gallium, right?
Right.
It would be right here.
Right.
I hope that's what you meant.
Right.
It's below manganese, but it's above gallium, right?
Right.
Because it's above all of them, so it's got to have the highest ionization energy,
Right.
the plus 3 power.
Mm-hmm.
Good. We're finished with plus 2. Now tell me what are all in plus 2 pile. Let me get a different color so I can write them down. What are all in the plus 2 categories?
There's calcium,
Okay,
Ba,
okay,
copper, Cu,
okay,
iron,
okay,
manganese,
okay.
and I forgot what the Pb stands for.
Lead. It's lead.
Okay, lead.
Okay, is that all?
Mm-hmm.
All right, we don't have a plus 1, so if you finish this, we're pretty much done with our problem, right?
Right.
Again, if you go pick the one that's in the rock bottom on this list, that's going to have the lowest ionization energy, provided there's nothing else in that same row, right?
Right.
I believe we have
Pb.
Pb and barium, right?
Mm-hmm. Ba.
Okay. So all these plus 2s are going to be smaller than the plus 3s, right? But
Right.
we have 2 on the very rock bottom. Which of these two would have the lowest?
Barium.
Very good, Daniela. That's it. Barium 2 plus, right? And then Pb 2 plus. All right, we're done with Ba and Pb.
Okay.
Moving on to, we're done with row 6. Is there any element in row 5? I don't believe so. There is no ions that matches any elements in row 5.
Nope.
Okay, we're moving on. Our search came vacant, right?
Right.
Moving on to row 4. You can always be guaranteed there's going to be something in row 4, okay? Row 4 is an element that's used, up to row 5 is what mostly used in our daily life.
Okay.
So I would never test past 5, but 6 is okay. All right, on row 4, what are the ions?
We have copper.
Okay, let's
We
circle
have
copper.
iron.
Okay.
And you have calcium.
Manganese.
Oh, and manganese. You're right.
Yes, see, this is why we're doing this. Even if you miss one, that's you will eventually find out. But what happens is some people lose the frustration because of frustration and go for a choice because they forgot one and now they have to put it in the right order. It's not like you missed one, you missed the sequence.
Right, right.
So you want to go, all right, we finished these. That's why I'm striking it out, right? You know that these 4 have higher ionization energies than the one we've already finished. But out of these 4 circled in pink, which one would have the highest ionization energy?
Copper.
Very good. Copper, and work your way back, right? Iron. And then manganese. And then calcium.
Calcium.
That is it. Let me go ahead and, as always, get rid of this at the top and write the full sequence. Again, this is none of these problems are the exact same homework problem because then that beats the purpose of learning. I would never do that. So let's go ahead and write them. Ba2 plus, Pb2 plus, Ca2 plus, Mn2 plus, Fe2 plus, Cu2 plus. What do you think is the benefit of this method, Diana? What do you think, besides the fact that you see it very clear, what other benefits does the approach that we just did offers to not just you, to many of you in the class? What do you think it does? What are
you have to take your time so you don't leave them out.
Leave them out, that's one. And then you're not directly putting them in the sequence. You're doing it like your freehand version. And
right.
You get files like this and rules. Again, you will have the video in front of you when you take the test. So, you know, there is absolutely all these videos are in my channel. So even if you click on my channel, you'll be able to see all the videos. Because when you take the test, you may not be able to log in Moodle twice. I'm saying that. You may want to have my YouTube channel open while you take the test if you're going to watch the video simultaneously. Because the video links are in the Moodle. If you try to open it, then it'll kick you out of the test.
Okay.
So you don't want to do that. While you take the test, you don't want to try to open a Moodle link from Moodle itself. That's going to think you're getting out of Moodle and exit you out of the test. Okay. This is a safe, clean approach. I don't know there is a better way to do this because given the monstrosity of how many elements we have. Trust me, this is how many you will see on the test too. Okay?
Okay.
What I'm trying to do is prepare you for any board exams you will take. The board exams will have complicated situations like these. Everything is going to be conceptual. All these questions, and I'm not teaching anything in this class that's not going to be on your nursing or any of those general things people can understand. So what I'm going to do is the next one, I am actually going to make up some questions, ions, okay? This is purely made up. I am not going to, I will still bring my periodic table back, but this question 4 is a degree of difficulty for some of you at 8 out of 10, okay? Starting with question 1, the degree of difficulty has increased, if you've noticed, okay? So This question, most likely I will only ask this way, because if I ask one more method, which I've never taught you, any of you, more likely you would struggle, and I don't want that. All right, something like this, okay? We got combinations of it. Okay, salt ions slash elements, because there's combination of everybody in the pile. Salt ions elements in the order of increasing size. I will not try this combination with ionization energy. I can tell you that much, because that's much more difficult in order of increasing size. And smallest to largest. This is going to take you some time, so I'm going to give you like 5 minutes and see what you can come up with. I'm going to underline it for dealing with increasing size. This is a pretty generic question, if I would say that. If you can do this, that really shows you've got it. This is the ultimatum of that whole sequence.
Okay.
This is degree of difficulty somewhere around 8 out of 10. So if you don't get this question right on the test, try to manage it with a bonus question. Don't try to, spend a considerable amount of like half an hour on this one. That's not worth it. Basically, you have to put everything you've learned into work here.
I haven't finished it.
Okay, let's go look at it. All right. What you could do is, once I finish the video, you probably won't remember most of it. If you have the list down, go ahead and give it a shot yourself. Okay.
Okay.
But here's how you. This is like I said, this is degree of difficulty is pretty high on this one. Okay. If you see this one, give it a shot. If you think it's going to take more time, just skip it, go to a different one. Okay. I don't want you to be spending 45 minutes on one question either. That's not worth it. Okay. Now, this is very difficult because it's got combination of everybody in the pile, right?
Mm-hmm.
We have done one problem, not on the homework, but on one of the practice videos we have done. Okay. I think I did one on my videos itself. So here's how we're going to do. Split the positive ions in one group.
Mm-hmm.
split the neutrals, which is element with no, just a regular element, and then we're going to split the negative ions into a pile. Okay. All right, let's go get the positive ions, which is Cr3 plus, right? Iron 2 plus. And this is more psychological. I purposefully don't give all positive in one go because that's the way students think. They read from left to right. So this is all there is. Okay? Neutral, F, Cl, Ga, Se, Sn, and O, right? Negative ions, O2 minus, O minus, S2 minus, and
Cl minus.
1 minus, right? Now, what have we learned all the entire week 2 is, or week 3 is, week 2 is, positives are going to be definitely smaller than neutrals. Neutrals are going to be smaller than negatives, okay? As far as the negative, I would like to create that extra rule. More negative charge, the more negative charge, the bigger the ion, and then you apply rule if there's more than one, okay? That's why I said this particular problem just completely tests you the entire concept, okay? All right, so with that said, let's go ahead and leave some space so I can start working this out. Okay, I'm gonna just delete this because that's the only space I have to not delete anything else and continue to work. All right, Diana, which one do you prefer? Do you prefer to start with the smallest to largest or largest to smallest?
Smallest to largest.
All right. So we know positives are smaller than the neutrals and the negatives, right? Irrespective of where they are.
Right.
And we just did a positive question 3. One with the most positive charge is going to be
the smallest.
Smallest. All right. That's easy.
Yeah, man.
There's only one, so no problem. Okay, I'm going to start putting it in the sequence itself because we're out of time. So we have still 2 more, right? Well, we finished this. We still have 3 more. Out of this 3, which one is a little bit more positive?
Cr.
Okay, so that's going to be bigger, right? So that's going to be a little bigger than Mn4 plus, but it's smaller than the rest, right? Now comes the question. Iron and tin. We're dealing with size, remember? So where is tin with respect to iron?
It's
iron
below it.
Above tin or below?
It's below.
Okay, so is tin has bigger size or tin has smaller size?
It's going to be a smaller size.
No. Iron 2 plus and tin, right, Diana?
It's going down, right?
Yeah, so it's going to be bigger, right?
Bigger.
Okay, keep that rule in mind, okay? That's what's going to save you, okay?
Yeah, that's where I'm getting
confused. In the long run, I think you will forget things. All right, we're done with the 4 positives, right?
Right.
Now, what I mean by down is if it is anywhere below that row, that it is down, okay?
Okay.
Down does not mean it has to be directly below that element. Down means it is below that element. Like if you think of it as some kind of steps, clearly tin is below iron.
Right.
That's what I'm saying. All right, we're done with the 4. Now moving on to the neutral, okay?
Okay.
Again, pick the one that is at the rock bottom to the right out of this 6 things here. Which one is at the very rock bottom on this list? I know which one it is.
Sn.
Very good. It's the same as Sn, right? So that is going to be the biggest of this pile, right?
Okay.
So I'm going to leave some space and then go to the Sn, okay?
Okay.
All right, Sn done. Who else is in this? Is there any element in the same row? No.
No.
We're done. Row 4. Is there any element in row 4 that's in that list?
There's Ga.
That's it, right? Ga and Se, right? You see that?
Right. Se.
Okay, they're both about tin, so they're smaller than tin, right? And out of those 2, which one is bigger? Ga or Se?
Ga.
Very good, right?
Mm-hmm.
Okay, that's done. And then we have three more, right?
Right.
We have chlorine, we have fluorine, and oxygen, right?
Mm-hmm.
Chlorine is definitely above all these guys, right? So it's
Right.
smaller, right?
Mm-hmm.
But it's below these two guys, right?
Right.
And out of oxygen and fluorine, which one do you think is bigger?
Oxygen.
Very good. That's it. Where this is where that what I meant to say is this. This is where it's continuing, right?
Mm-hmm.
All right, let's keep going. We got all of them done, right?
Mm-hmm.
Moving on to the last one. Out of these four, which ones have the most negative charge? Let's go get a different color. It's these two, right?
Mm-hmm.
They have more negative, right?
Right.
They're both bigger than these two folks right here.
Right.
But out of these two, oxygen and sulfur, which one do you think is bigger? Where is sulfur with respect to oxygen?
It's below.
So it's bigger, right?
Mm-hmm.
So S2 minus, it's at the very end, O2 minus. We're almost there. Two more. Oxygen and chlorine. Oxygen is here and chlorine is here, right? So chlorine is bigger than oxygen. That's the list.
Okay.
See how I did that? I did not do any magic, or I did not deviate from my systematicity. And this is the only way. This is the comprehensive problem. Okay, this is, as I said, it's very, very difficult. I wouldn't recommend, if you can get the answer right away, you may want to come back to it, but I wouldn't spend like 50 minutes on one problem. That's just going to put unnecessary panic mode in you, and
Okay.
you don't want that. One last thing is, this is not something, I don't want to work out a problem, but when writing I'm just going to write this as a tip.
Okay.
When writing electronic configuration, I know there's a few that are comfortable writing the direct sequence, but again, that's where their problem is. When writing electronic configuration, I highly recommend you follow these steps if you don't want to get it wrong, because I know my students, and I'm very good at creating a test. So I know exactly where each student struggles. And I've even told you all that, and I give you the secret, and I still go ahead and do it. Always write the incorrect sequence. Always write the incorrect sequence. That is, you follow the pattern that's in that image that I've given you. And then fill it with electrons. And then maybe we can do one example for that, just to do fill it with electrons and then shuffle. Threes with threes. Fours with fours. This way, you're not going to get it wrong. I think only 2 or 3 people got this right on the homework. Copper 2+. First, write for copper. You don't write for, unless you're really comfortable. I'm not discouraging any of you from going too forward. But if you are going to make a mistake out of that, being positive and going straight, then you might as well take a step back. So this is what your incorrect sequence would look like. I don't think people have got it. This is exactly what copper looks like, Diana, right?
Mm-hmm. Mm-hmm.
Now you don't write Cu2+. You got to go first, fix the sequence. So the 3D comes here, 4s comes here. Because this is not your valence orbital, and that is why I am saying that is, if you don't make that correction, you're going to consistently be taking electrons out of where it's not supposed to come out.
Okay.
This one problem I'm more than happy to solve for all of you, because like literally everybody got this wrong, except for a couple of people, right? This is for copper, not for copper 2+.
Right.
Now let's go get copper 2+, which is You always remove electrons from, maybe it's just for D, D is a separate rule. Always remove electron from the furthest orbital. From the furthest orbital. What I mean by furthest from the nucleus. Orbital or orbitals. It could be, sometimes you continue to remove. So in this case, 4s is the furthest. And 2 plus means I got to lose 2 electrons, right?
Electrons.
So that whole thing is gone. And this is foolproof. This will never let you down. I mean, if you want to get this thing right every single time, right on the test, you may do fine now because I just reviewed it, but for the final, it'll be a while before you have seen this.
Okay.
Again, the level of material we've done for 3 exams is very minimalistic compared to some other online courses. I think even the way it was set up, I think it was almost 6 or 7 chapters. So that was a lot of material. There's no way, no one could have read all those chapters in 3 weeks and handled all those problems and quizzes. So the course you're looking at is not the course I looked at. It's completely remodeled from scratch. Everything is. So still, by the time you get to final, that's like another 3 weeks from now, you won't remember this, right? The course is only 8 weeks. We're currently in the 5th week, I believe, right? We're heading into the 5th week soon. So there's only 3 more weeks. You may not remember this, but if you remember the steps, this is foolproof. You're never going to get this wrong. This is the correct answer.
Okay.
What some of them did is they wrote it from here and they removed the 2 here and then flipped. You never remove electrons before you flip. You flip first and then remove electrons. What people did is they wrote this, removed the 2. Let me write the incorrect one. This is incorrect. Because they don't flip, they remove and then flip. That is incorrect. That's not how I taught. You have to first, this is what everybody did, and then they flipped. This is incorrect. And then they flipped to get the right answer, which is still, I will not. And also, if you didn't write the correct sequence, like if it's not flipped, I would still not give credit on the test. It has to be flipped. It has to be removed correctly. That's why.
Okay.
Because this is incorrect. If you show it to a chemist, they would straight away disprove and say that's wrong. No chemist would give credit for that one right here. This, every chemist will give you credit for. So keep this tip in mind, because technically exam 2, a lot of it is about the sorting and the electronic configuration. There's a few from week 3, because week 1, 2, 3 are the ones for exam 1. That's how it's in the syllabus. But I've tried my best to share it evenly so no one gets stuck with one particular concept forever.
Okay.
This is my tip. If you follow this when you deal with electronic configuration, the chances of you getting anything wrong is almost not there. I won't even say slim to none. It's just practically not. If you try to cut short and save time and go straight for the kill like it's in the top, that's what happens. This is what happens when people go straight for the, you don't save any time. You actually lose points if you by getting it wrong. And the total test should take about 40 minutes, but you have 2-hour window to take it. So you can take it anytime from tomorrow morning 6:30 till Sunday midnight 11:59.
Okay.
I don't recommend you don't open the test until you watch this session again and redo some of the homework problems one more time.
Okay.
And I will post the key for homework 2 Saturday morning, because some people are still turning in the redo, so I don't want to post the key. But the key for homework 2 will be available on Moodle starting Saturday morning. It's already there. It's hidden right now. You can't access it, but when Saturday morning gets there, so you may even want to use the key one more time and then redo the test. So that's my recommendation. When you are thorough with the material, then going over something that you're haphazardly not sure about it.
Okay.
All right. So this pretty much summarizes everything we have done. And I know that week 3 material is a little bit easier. It's not as PDF is good. So if you run into any problems, don't ask me specific questions, but in general, if you have questions, email me. Okay.
Okay.
All right, Diane. I'll see you later.
Okay. Thank you.
Bye bye.
Bye bye.